Today we're going to discuss solving linear absolute value functions. Our learning target is I can solve a linear absolute value function. First, let's think about what value we can plug in so that the absolute value of x equals 5. If you recall from our sponge last week, -5 and 5, when the absolute value is taken, will both give you an output of 5. Think about what you can put into the absolute value of x to get an output of positive 10. Positive 10 equals positive 10, but also the absolute value of negative 10 equals 10. So negative 10 and 10 are both input values that will satisfy the absolute value of x equals 10. Now let's look at the following equation. F of x equals the absolute value of x minus 4. If we look at f of x when x is 7, or f of 7, and we look at the absolute value of 7 minus 4, we can say that 7 minus 4 is 3, and the absolute value of 3 is 3. Therefore, f of 7 equals 3. The flip side of that is looking at f of x equals x minus 4 when f of x equals 2. So think about what you can plug in for x to get an output of 2. First that comes to mind is 6. When x equals 6, that's 6 minus 4, which is 2, and the absolute value of 2 is 2. But what about when x equals 2? 2 minus 4 is negative 2, and the absolute value of negative 2 is positive 2. So both of these solutions work. F of negative 3 looks like negative 3 minus 4, which is the same as negative 3 plus negative 4. So that's the absolute value of negative 7, which is positive 7. So f of negative 3 equals 7. And the last one again is when negative 5 equals the absolute value of x minus 4. So what values can you plug in for x such that the absolute value equals negative 5? If you said no solution, you are correct. There is nothing that we can put in for x so that the absolute value provides a negative. That takes us to our next slide. Recall from 5th and 6th grade that for every input value, that's every x value of an absolute value function, the y value is non-negative. That means that the domain, the x values, are all real numbers. You can put negatives and positives in an absolute value equation. However, what comes out of an absolute value equation are only positive numbers. So y is greater than or equal to 0. So anything can go in, but only non-negative values can come out. Let's practice solving linear absolute value functions. Recall that the input can be any value, both negative and positive. So When we go to solve the absolute value of negative 3x equals 21, we must look at both sides when x is positive and when x is negative. So first step is to look at the positive side. So we're going to trade those absolute value bars in for parentheses. And if these were parentheses, we would simply divide both sides by the coefficient, and we would say that x equals negative 7. So if we test that, the absolute value of negative 3 times negative 7, we get the absolute value of negative 21, which is positive 21. So that works. The other side to the equation is to look at the negative value. So what happens when the absolute value is negative? So just as any equation, we would distribute the negative value. A negative times a negative is a positive. So you get 3x equals 21. Divide by the coefficient. And x equals 7. So if we check that, negative 3 times 7, you get negative 21. And the absolute value of negative 21 is positive 21. So that checks out. So the solutions to negative 3x equals 21, x equals negative 7, and x equals positive 7. Make sure you're recording these on your guided note sheet. Let's look at another equation. Let's look at x divided by 5, the absolute value of that, equals 1. Remember, first, we look at the positive side. So we're going to trade the absolute value bars in for parentheses. And if that were a typical equation, we would just multiply by 5 on both sides. And x equals 5. So that's going to look like the absolute value of 5 divided by 5 equals 1, and 5 divided by 5 is 1. Absolute value is 1, so that checks out. And then we must look at the second alternative, which is if the absolute value quantity was negative. So what happens when we have a negative x divided by 5 equals 1? We would first divide both sides by negative 1 to get rid of the negative sign. And that would leave us with x divided by 5 equals negative 1. So we'll multiply by the denominator. And that gives us, I'm going to go back up here, x equals negative 5. So if I plug that back in, negative 5 divided by 5 is negative 1, but the absolute value of that is positive 1. So that checks out. So the solutions that satisfy this linear absolute value function are x equals 5 and x equals negative 5. Okay, the last one I'm going to walk you through is the absolute value of negative 4 plus 5x equals 16. The first step is to look at negative 4 plus 5x when the value is positive. So I'm going to treat it just as a normal equation. I'm going to add the constant to both sides. That's the inverse operation. Get 5x equals 20. When I divide by 5 on both sides, I'll get x equals 4. The alternative is when the input value is negative. So let's look at it from this side. So just as any equation, you have to distribute that negative through all terms inside the parentheses. So a negative 1 times a negative 4 is a positive 4. And a negative 1 times 5x is a negative 5x. I'm going to subtract 4 from both sides. That's the inverse. And I get negative 5x equals 12. And when I divide both sides by negative 5, I get x equals negative 2 4/10. So the third step, the final step, is to check the solutions. So if I plug in 4 back into the original linear absolute value function, that's going to look like negative 4 plus 5 times 4, and 5 times 4 is 20, minus 4 is 16, and the absolute value of 16 is 16, so that checks out. And the second solution was negative 2.4, so the absolute value of negative 4 plus 5 times negative 2.4, 5 times negative 2.4 is negative 12, and negative 12 plus negative 4 is negative 16, and the absolute value of negative 16 is 16, so that also checks out. So the solutions to absolute value of negative 4 plus 5x equals 16, x equals 4 satisfies that, and x equals negative 2.4. Okay, I'd like for you to try this problem. Solve the following linear absolute value function. Negative 5 times the absolute value of 3 plus 4x equals negative 115. So if you'll go ahead and pause the video, when you think you have a solution and you've checked your solution to make sure it satisfies the absolute value function, then go ahead and click play, and you can self-assess to check to see if you solved it correctly. Okay, go ahead and pause. So here are my solutions. X equals 5 and x equals negative 6.5, which is the same as negative 13 divided by 2. Is that what you got? Check to see if your work matches mine. One of the key points that I'm going to point out here, I had to first divide by this negative on both sides before I could make the left side negative. So you can only evaluate positive and negative if you're just changing the sign of what's inside the absolute value. If you were struggling, that may have been your catch. The last piece of your guided notes is to summarize. You have heard me mention the steps for how to solve linear absolute value functions. Explain to a new student how he or she would solve a linear absolute value function in 3 steps. So you've heard me say the steps multiple times now. You may want to go back and rewatch, but I want you to summarize how to solve a linear absolute value function in 3 steps.